We have today Miss Sarah's 5th grade class from Willis. I'm glad you all are here today, and also a group called Virtual Touch out of the Center for Human Computer Interaction. So we have Wallace and Sarah and Min and Nanlin. So I'm going to just turn it over to them at this point.
Yeah, I would just say that we're super excited to be here. I hope we can show you some interesting stuff that we have been building over the last year or so that involves like robotics and involves virtual reality and games.
So hi guys, I'm Sarah and I'm an architect. So I joined this group because of my concerns in architecture. As an architect, I've always been concerned about the spatial qualities and the impacts of it on the built environment, because our world is now having the dominance of sense of vision, and well, this dominance has led to neglecting and suppression of the other senses. And so we thought that there is a need to have a process towards a multi-sensory architecture, I mean, from my point of view, and the one that promotes a sense of belonging and integration with the space. Our question was that how to promote a sense of touch in the VR. So we thought how to promote sense of touch in VR and create integrated spatial sensation and experiences. And we also think how we can promote the architectural understanding and the perception of the built environment to also engage the spatial qualities such as proportion, visual connections with the environment, and from the other hand, like to engage materiality, sensation of the materials and their properties. So what we think of in our approach is to use robots to create haptics dynamically to the user. So the robot would move from one location to the other place and kind of predict what the user might do as the next level. In general, we propose using mobile robots to create physical surfaces around the user. One study that we did is to design a game that involved the user to execute a puzzle while pushing a physical object, which was a box in our case, to simulate haptics. The next one that I was more engaged is creating a kind of deployable and movable furniture that was positioned on top of a robot. This architecture scenario was more complex, and so the robot also needed to predict where the user may head.
So that's enough about the why. So let's start talking about the how. So do any of you kids like cars? So imagine a car, but smaller. This is the Robotnik Summit XL. It is a small car that can move around, and we're using this to power our frame. Now, we're using special wheels on this car to allow it to drive in any direction it wants, including sideways. You can see these wheels here. Now, what makes this really interesting, it gives us a lot of control over where this car goes. As you can see by this video, you can even make it move sideways. Now, this is really useful because it allows us to move our frame and our wall to wherever we want it to move in the space to sync it with the VR. So let's say that here we have our new version of the bot, which is the one that's being built in my apartment right now, and we have a person who wants to interact with the wall. Since we have our wall on wheels, it can move up to the person and extend its wall to meet the man in front of it. This bot moves around on the floor wherever it needs to move. And let's say this man, instead of wearing glasses, he's wearing a VR headset, and he finds a wall in front of him. So at this point, the robot can move up in front of him, position itself in accordance to where the wall is and that he sees, and extend a wall in front of him. So when he puts his hands out, he can feel that physical impact. This whole thing is powered by lots of actuators. And an actuator is something like this. The top part moves up and down, and you can use that movement to, well, move things around. In this case, it's a wall. So we have a car that's moving a wall and a table around, but also it can work as a chair if this were to spin around and extend this section downwards. All this works into play in order to link up with a game. And this game is currently being set up by Natelin, who I'm going to pass off the presentation to now.
So we mentioned about the game, which is called the Sokoban. It's a puzzle game. So what you do is you act as a character here. So what you're going to do is push the box into this red dot, like this. But there will be cases that you cannot move this box that is in the corner. So you have to move wisely. These and that, you push over, push down and down. But I think that's a dead end. But you get the point. The point is that you have to push all the boxes into the goal, which is the red dot, in order to pass this level. So with them, based on this design, we want to build that on top of our project, which is the Sokoban. So this is the game scene I was building for. So as you can see here, this is a bank vault. We have multiple cards over here. So this is the card number 1, and we have another card which is full of money. And the people need to push this card from these laser fans. So when the game starts, there will be laser fans around here. And they need to push this card out from here to the destination. But as you can see here in the game, there are 2 cards. But in the reality, we only want to have 1 robot. So what can we do? Want to detect, like when the user is approaching one of the game object, game card, we want the robot to move automatically from one point to the other. So in the game world, there will be multiple cards that show in the game scene, but in the reality, there will be only 1. So that's basically what we are trying to do to predict the user movement at this point.
So just what you see now is what the player will see inside the VR headset, right? So even though the person is in a regular room, it just feels like it's inside the bank, right? And the general problem is that in VR you can see all these different things like in games, but you cannot actually touch any of the things that are inside there, right? So by combining what like Sarah said in the beginning and the actual physical robot that Min explained about, we can have an environment where you can see like the scene of the bank, and you can also go and touch certain objects inside there. In this case, these money cards. So what you can start to do here is to find a way to move this box around, but instead of using a controller, right, as you play like video games in your home, you can actually go with your own hands and push this card around. And what we did was design just around this like bank scenario. So your goal here is to try to get the money outside these laser shields by pushing these cards around with your hands, but without activating the alarms. Right? So what Nelly is showing here is like pushing this block over the pressure sensor that will then deactivate the laser fences so that he can get the money out. So it's just an example how you can apply like robotics and VR to make like more interesting games that you can actually touch things besides just seeing them in VR.
This isn't really an intent to be sold in stores. This is more research, so we can pass this off to other people who have a bigger teams or bigger games, so that can be buy them in stores.
How do you really use the carts? Like, does the cart predict what you're going to do?
If you're asking how we move the cart, do you know what virtual reality is? Something you put in your head and you can see a scene that isn't actually there. But the problem with that, if you move your hand out, since the scene isn't actually there, your hand just goes through walls and through other objects you're trying to interact with. So normally in those types of games, you would have a controller, which is like a remote for your TV. So you pointed at something and then you tell it, I want to move you over there. But it's a remote and the object isn't actually there. What the robot is doing is it moves to where that object is that you see. So not only can you see it, but you can also feel it by putting your hands on it. With that, you can move that around by just pushing it as you would push a box in real life.
So I just want to thank our team today. Thank you for the team from Center for Human Computer Interaction, and also thank you to Ms. Sear's class, both the in-person folks and the folks who joined us online.
Hi, thank you for the questions.
Stay safe.
Bye.
Bye.
Have a good day.